Have you ever stopped to think about how our digital world just works? Behind pretty much every app, every website, every single transaction, there's this hidden language pulling the strings. It's called SQL. Today, we're going to pull back the curtain and decode it. And trust me, by the end of this, you'll see the world around you in a totally new way.
Let's start with something you do every day. You tap your card to buy a coffee, and like magic, your bank instantly knows your exact balance. How? Well, it's not magic. It's a database. And the real secret isn't the database itself, but how we talk to it. To understand that, we have to go back in time a bit, to a massive data problem that we absolutely had to solve.
Before computers really took over, our data lived on paper. Just try to picture it. Endless filing cabinets, library card catalogs, and these phone books the size of a brick. As the amount of information just exploded, trying to find any one thing, well, it became a total nightmare. And this really shows you the heart of the problem. Think about one of those old phone books. I mean, technically it's a database, right? But let's be honest, it's a terrible one. It's super slow, you can only search one way by last name, and the second it's printed, it's already out of date. So moving to modern databases wasn't just some small upgrade, it was a complete revolution. It gave us a system that's lightning fast, incredibly flexible, and always current.
So how do we go from all that paper chaos to perfect digital order? Well, the answer was this brilliant idea from the 1970s called the relational model. And honestly, the best way to wrap your head around it is to think of it as a perfectly organized digital library.
Let's break this metaphor down. The entire database? That's the library building itself. Inside, you've got bookshelves, and each one holds a specific category of information. We call that a table. So maybe you have a customer's bookshelf. Each individual book on that shelf is a row. That's one specific customer. And the facts inside that book, like their name or city, those are the columns, kind of like chapters.
And here's what that actually looks like. This is a simple customer table. See the columns up top? Those are our chapters. And each row is one of our books, a unique customer. It's clean, it's organized, and it is unbelievably efficient.
All right, so we've built this amazing digital library. It's perfect. But now what? How do we ask it for a book? We can't just shout into our computer, right? We need a special language that the library understands, and that language is SQL.
This quote really nails it. SQL lets us do, well, everything. We can build the bookshelves, we can add new books, we can edit the books that are already there, and, this is the most important part, we can ask really complex questions to get exactly the information we need.
Now get this, because this is the real magic of SQL. It's what we call a declarative language. That means you don't give the database step-by-step instructions. You just describe what you want, and the database is smart enough to figure out the fastest way to get it for you. It's like asking a librarian for that book on Roman history, not telling her, go to aisle 3, 4th shelf up, 7th book from the left. You just say what you want, and the system handles the how. That's what makes it so powerful.
So how do we actually speak this language? It's actually pretty simple. It all boils down to just 4 core commands. You can think of them as the 4 main verbs you need to manage everything inside your digital library.
When you think about it, there are really only 4 things you need to do with data. You need to find it, add new stuff, change things that are already there, or get rid of stuff you don't need anymore. In the world of SQL, those actions are select, insert, update, and delete.
Okay, let's start with the big one, the workhorse of SQL, select. This is how you ask questions. And the cool thing is, it almost reads like plain English. We're just telling the database to select the first name and last name columns from our customer table, but only where the last name is Smith.
And boom! Just like that, the database finds the exact book we asked for, opens it up, and gives us the chapters we wanted. Super fast, super precise.
So that's how we find stuff. What about adding a new book to our shelf? For that, we use the insert command. We just tell the database which table to insert into, we list the chapters or columns we have info for, and then we give it the values for our new person.
And there we go. John Doe is officially in the system, all filed away and ready for us to find later with a quick select command. Pretty easy, right?
But, you know, information changes. People move. So what if George Blake moves to a new city? No problem. We use the update command. We tell the database which table to update, what to set the new city to, and, this is super important, we use where to tell it exactly which row to change. You have to be specific, or you could change the wrong person's info. And just like that, it's done. George Blake's record is updated. This right here is the magic that keeps your bank balance and all that other real-time information perfectly up to the minute.
And finally, we have delete. This is for when you need to permanently remove a record. And just like with update, that where clause is absolutely critical. It tells the database exactly which book to pull off the shelf for good, because if you forget it, you might accidentally wipe out your entire customer list. Seriously.
And poof, she's gone. Sue Smith's record has been removed. So that's the whole toolkit. Select, insert, update, and delete. Which is those 4 simple commands, you have total control over all the information in your library.
So I know what you might be thinking. A language from the 1970s? Isn't that, basically ancient technology? You'd be surprised. It is more important today than it has ever been. It's truly the unseen engine that runs our entire modern world.
So why has it lasted so long? Because it's still the best, most solid, most reliable way to work with structured data. Every single time you use your banking app, book a flight online, or look at a sales report for your job, you can bet that SQL is humming away in the background. It's become a fundamental skill for so many careers for one simple reason. It's the bridge that connects us to our data.
And at the end of the day, that's what it all comes down to. We live in a world that is completely run by data. So learning the language we use to speak to that data, well, that's not just a tech skill anymore. It's a whole new kind of literacy.